this is the lab 2, which is about diode circuits. It tells about the digital logic gates made from the diodes. In the first part, we are going to make a diode logic gate using the LEDs. So we have one diode here, another diode here, and we will be setting up the supplies here, and we will be checking the output. The output, instead of diodes, we will be using the LEDs. So we have 3 LEDs here, and the final output current is passing through 270 ohms. So you can check on my circuit setup here. So I have the diode number 1, and then this is my diode number 2, and this is my diode number 3. So the input is coming from here. This is the green one is the input number 1, and the red one is the input number 2, and my output the output LED is here, and this is a 270 kilo ohms, and this is my global ground. Okay. When we switch on the supply, when both of the inputs are connected to VDD, you can see my output is high. So let me change one of the input to ground. The input green is still connected to high, so that LED is on, but the second LED become off, and my third LED, and my output LED is still glowing. Now I connect back the input to VDD, and my input 1 to ground, and you can still see that my output is output LED is glowing. When I shift back both of the inputs to ground, you can see my output LED stops glowing. So this circuit logic is for OR gate. The logic diagram, I have mentioned it here. So this is 1 1, you get an output 1, 1 0, you get an output 1, 0 1, you still get the output high, but when I connect both of them to ground, it becomes the output 0. Thank you. Guys, we are going to do the E2 part of our circuit. So we are going to build the half-wave rectifier circuit. I have to apply a 4-volt peak-to-peak input with 1 kilohertz sinusoid sine wave. To configure, this is my circuit. Here's my input, and it is going to the PN diode, and then I am taking output from a 100 kilo ohm resistance. So here the solid line represents the input, and the dashed line is my rectified half-wave rectified output. So you can see whenever the positive signal is passing, diode is able to pass, but during the negative cycle it is not able to pass the signal. To configure the waveform generator, first I will select the frequency of 1 kilohertz from here. Then I'm using a sinusoid signal from here, and my amplitude is set with this. So I'm setting the amplitude to 4 volts. So from here my output comes in, and my input comes in. From the green wire, I'm taking the input. Here is my PN diode, and here is my 100 kilo ohm resistance. So one thing you need to consider is the direction of the diode. The N is with the black ring. For the ground, another thing you need to consider is the ground. I'm using the supply ground here, so this ground goes in here, which goes towards my supply. You can use the scope ground also. So I'm on channel 1, with the help of this magenta wire, I'm measuring my input, which is the yellow sinusoidal signal, with the red curve here, red wire here. At the output of the diode, I'm measuring the rectified output, and on the channel 2, with the cyan color, you can see the rectified output. In the E3 part, we are supposed to insert a capacitor between the diode output and the ground, which is in parallel with the resistance. So I have put a 100 femtofarad. Let me cross verify. 100 nanofarad capacitor here, and you can see from my output here that now I'm able to hold the rectified output more, because now with the capacitor is charged and you get the rectified output like that. Thank you. For the AM modulated signal, this is this is my input signal which are sending it, the carrier signal. On the carrier signal is modulated with an AM signal here, which is passed through the diode and the resistance. So in this case, to modulate it with AM, on this part of the generator there is this button known as AM. So we are going to press it, then we are going to set the range. So I am setting in the range of 100 of hertz. So you can change it, the frequency with this knob and the amplitude with this knob. So for to see the effect, you can see now you have to reduce the time scale. You can see on my output that my input signal is AM modulated, and you can see in the output also you see the rectified also is output is also AM modulated. And you can see from this the peak rectifier output rides on the top of the waveform of your AM signal. It's a little bit less because of the voltage drop across the diode. Thank you. For the E4 part, it is told like that we need to add a 5.1 kilo ohm resistor in parallel with a 100 nanofarad capacitor. So the overall circuit will look like this. Now we have additional 5.1 kilo ohm resistance in parallel with 100 nanofarad resistance. So in circuit here I have added an additional resistor in parallel with my capacitor and resistance. So you can see from the output waveform that it is now discharging much more quickly. It's because earlier the time constant was quite high because of 100 kilo ohms in parallel with the capacitor at tau equal to RC, and my R is quite high. But when we add a 5.1 kilo ohm in parallel, the overall resistance drops, so my tau is smaller, so my capacitor is able to discharge much more rapidly. So you can see from the, you can note this waveform change when you add the 5.1 kilo ohm resistance in parallel. Okay guys, for the E5 we need to build a charge pump circuit as shown in figure 2.4. I will be using the 5 diodes and 0.1 microfarad capacitors. So first we need to configure the input to 1 kilohertz, and the supply has to be from -2 to 2 volts, and the signal has to be square wave. So to configure that, we comes to the signal generator. I have set my frequency to 1 kilohertz, select the range of 1 kilohertz, and I have set it to the 1 kilohertz frequency range with this knob. Now for the amplitude, I will use this knob to set the amplitude to -2 to +2. So you can see on the channel 1 I have recorded the input signal. So you can see from you can see the signal -2 volts to +2 volts here. Now to select the square wave, I have pushed this button. So here is my whole circuit. First I will show the circuit in the handout. So there is a diode, then there is a capacitor C1, then diode D2, then after C2, diode D3, C3, D4, C4, D5, and C out. So on diode D1 input, we are applying the input square wave with plus VDD and minus VDD, and the capacitor C1, C3 second plate is grounded, and also the C out is grounded. So we are here, let me explain you what is happening. Here the signal is coming in from the signal generator. Now with this cyan color, my signals, I have passed the signal from, because this I have taken this strip, all the all the horizontal node like holes are connected. So I'm going to take the signal from here. This is my D1 diode. Cross check your polarity. This is P, this is N, and now this is C1 from this to ground, and for C2 is between diode D2 and signal. So cross check these connections. I have this one D1, D2, D3, D4, D5, and this is C1, C2, C3, C4, and C load. For the C load, the ground, I have used the ground of my supply, and this goes down to my supply ground, which is like this ground, which is connected to the ground of my supply. Now for the circuit analysis on scope 1, we are providing on channel 1 we are measuring the input. On channel 2 I will be measuring the output. So you can see this magenta color is my input signal, and now with this red wire I will be checking in my output signal. So first we will check at the node 1, which is mentioned in the handout. This is my node 1. You can see my signal is around around 2 volts, and you can also check it from here, min and max, that it is around 1.5 volts. So there is a little bit of voltage drop. That's because of the diode. It's not exactly VDD, which is 2 volts. It is less than that because of the drop across the diode. Now at node 2, and this is verified with the handout results. On node 2, I go to the node 2. I can see my signal is oscillating between VDD and 3 VDD. So my minimum is around 1 volt, and my maximum is around 5 volt. At node 3, my voltage goes to 3 VDD. So you can see from my minimum and maximum it's around 4.5 volt. And now comes the node 4. The signal oscillates between 3 VDD and 5 VDD, and you can see the signal is oscillating between 4 volts and 8 volts. Now comes the output. Output is around 5 VDD constant DC. So you can see my signal is around here, and my minimum is around 6.96 and my maximum is 7.1 volt. So you have pumped the charge pumped the input voltage from 1 plus minus 2 volts to 7 volt. Thank you. This is my whole circuit.